Hello everyone, this is G. Karthik Reddy, Associate Professor, Electronic Communication Engineering, MLR Institute of Technology, Hyderabad. Topic is probability and independent events. This is an overview of the contents. First, definition of probability, the concept of independent events, the characteristics of independent event, next concept of dependent events, real-time examples, problems related to the independent events. Now, what is the definition of probability? Okay, there are three definitions of probability. Probability, one of classical definition tells that it is a ratio of the favorable outcomes to the total number of possible outcomes. This is a classical definition of probability. Next, empirical definition is the ratio of the number of times of the event A occurs. Event A occur by total number of trails. Then the modern probability tells that the modern probability is based on set theory. It introduces the axioms, that is the rules that define the probability as a function from a set of events to a real number. The probability always lies between 0 to 0 and 1. It must satisfy certain conditions. The probability of the entire sample space, that is P of S, equal to 1. Next, probability of an event, that is probability of event must be non-negative. Next, for mutually exclusive events, the probability of their union is the sum of their individual probabilities. For example, P of A union B must be equal to P of A plus P of B. In this case, P of A intersection B equal to 0 because mutually exclusive, or you can also take for n number of events. P of A1 union A2 union A3 so on up to An. Then what you are going to get? P of A1 plus P of A2 so on up to P of An, which tells that the union is replaced with summation. This occur only when the events are mutually exclusive. These are the three definitions of probability. Now next, independent events. What are independent events? Okay, the events which are the occurrence of one event has no effect on the probability of occurrence of another event. Okay, means one is not influencing the other. We'll tell the examples, you'll have some clarity. In mathematical condition, if two events A and B are considered to be independent, if the probability of both the events happening together is a product of individual probability, that is P of A intersection B is equal to product of event A into probability of event B. Next, P of A represents event A, P of B represents event B, P of A intersection B represents probability of that both A and B occur together. If the condition is satisfied, then the given events are independent events. Now next, what are the characteristics of independent events? You are having different set of problems. If you are having no influence, means outcome of one event does not affect the likelihood of another event. For example, the rolling a die and tossing a coin are independent events because rolling a die is not depending upon the tossing a coin. The resultant of die roll has no impact on whether you get head or tail of the coin. Is correct na? Okay, head or tail is not depending upon rolling a die. Now second type of example is multiplicative rule. Multiplicative rule tells that probability of both independent events occurring is a product of their individual probabilities. For example, the probability of event A is 0.5. Probability of event B is 0.3. Probability of both A and B happening together, then you have to multiply both, that is 0.3 because second one is depending upon first one, that value is 0.3. Next, repeating independent events. In this case where the same experiment is repeated, like tossing a coin multiple times, each trail is independent of the others. Means tossing the first coin is not depending upon tossing the second coin. Tossing the second coin is not depending upon tossing the third coin. This type of examples also comes under independent events. Now, we'll take some examples. You'll have clarity about that. First type of example, flipping a coin and rolling a die. Just now I tell that flipping a coin. When you flip a single coin, what are the total number of possible outcomes? Only head and tail. Two possible outcomes. You are getting either head or tail. You are having only one possible outcome. Then flipping a head, 1 by 2. Flipping a, next rolling a die, 6. Okay, total 6 possibilities you are having. That is the denominator. Total number of possible outcomes is 6 and favorable outcome only you are going to get either 1 to 6, only one number, that is 1 by 6. Then since both are independent, one is not depending upon another, then you have to take the product, that is event is probability of head sign number 6, rolling a 6. Then what you are going to get 1 by 2 into 1 by 6, that is 1 by 12. Now we will take the second type of example, drawing a cards with replacement. Okay, we are picking the card and again we are placing on the same place. If you draw a card from a deck, replace it and draw another card, then two cards are independent events because one card is not depending upon another. Okay, this is the example when you are going to get, when your deck of 52 cards is there. For example, if you are selecting a ace, okay, in this example ace, okay, we are selecting ace from 52 cards, we are having total number of ace cards is 4. That is 4 by 52. Number of favorable outcomes is 4. Total number of possible outcomes is 52. Then probability of drawing two ace cards. First ace card is not depending upon second ace card. That is why you will get 1 by 13 into 1 by 13. That is 1 by 169. Next, third example. Okay, here we are discussing the dependent events. Dependent events is like an antonym to the independent. Okay, events are dependent. If the outcome of one event affects the outcome of another. We'll take some examples. Drawing cards without replacement. Okay, if you draw a card from a deck and do not replace it means it is depending upon another. Means same example I am taking, drawing a ace from a deck, that is 4 by 52. If you do not replace the card, draw again. Okay, and you draw the again, then it is depending upon, one is depending upon another, then what you are going to get? P of A intersection B is equal to P of A into P of B by A. Because here it is depending upon A, B is depending upon A. Next, key concept is, from these two examples we will conclude that independent events, no impact on each other. Independent events, one event affect the other. Next, real time example of independent events. Like you can take the weather and sports game. Okay, whether it rains tomorrow does not affect the football match take place indoors. These two are independent to each other. Now we'll take some more examples. Okay, we already discussed these two examples. Now next. Okay, now with replacement. With replacement, just now I discussed with replacement also. Now next, defective bulbs. Okay, factory produces bulbs. A factory is producing bulbs and 5% of them are defective. How many are defective? 5%. If two bulbs are selected independently, what is the probability that both are defective? Is telling that what is the probability that both are defective. First, how many probability that one bulb is defective? Okay, defective given that 5 by 100, that is 0.05. It is mentioned here. Okay, the probability that one bulb is defective. Since the bulbs are selected independently, it is given in the question, means one is not depending upon another. Means same we are going to get repeated. Means replacement 0.05 into 0.05. Okay, then that is 0.0025. Means that is 0.25 percentage. 0.25 you are going to get the probability that both are defective. Probability of both are defective means first one is defective, next Next, second one is defective. Okay, first one is defective. Both are independent means you are replacing. First one is defective and again you are without replacement. Again you are placing it. Then we are going to get this. Now next, independent events. In a toss a coin, roll a die. Just now I discuss. Next, passing two exams. Passing two exams. So the probability that student passes the max exam is 0.8. Probability that same student passes the science exam is 0.6. Assume that two events are independent. Means one exam is not depending upon another exam. Then you have to product both. Okay, first you have to define the events. What is the probability that student passes both exam? Then probability of passing the max exam is 0.8. Probability of passing the science exam is 0.6. When you product it, you will get 0.48. Then passing both the exams. Passing both the exams means P of A intersection B is equal to P of A into P of B. You do the product, then you will get 48%. 48% chance is the probability that the student pass both the exam. Now next problem. Two students solving a problem. Two students solving a problem. Here two students A and B independently attempt a problem. Probability of that A solves the problem is 3 by 4. Probability of the event A solves the problem is 3 by 4. Probability that B solves the problem is 2 by 3. What is the probability that problem is solved by at least one of them? At least one of them. Means at least means it may be 1 or 2. Okay. If you want, you can calculate at least. If I want to calculate at least of probability of the event at least, you can also have 1 minus none. Okay. 1 minus neither solves. Okay. That is why they are giving the probability of event A. P1 probability of event A plus probability of not solving the problem equal to 1. Probability of not solving the problem is equal to 1 minus P of A. That is 1 minus 3 by 4. That is 1 by 4. Next, probability that B does not solve the problem is same scenario. You are going to get P of B bar is equal to 1 minus P of B. Okay. Now we got the answer 1 by 3. Now neither both solves the problem. We product it. Then we will get 1 by 12. Now what we required, at least one of them means, just now I discussed, at least whenever they are given the keyword at least, easy way to 1 minus neither A or B solves the problem. Neither A nor B solves the problem. That is just now we calculated 1 by 12. You substitute 1 by 12, you will get 11 by 12. So therefore this is the result. Problem is solved by at least one of the student.